This is for Year 11 methods. It comes out of 17C, question number 6. Carefully sketch the graph of this truncus. Let point P be 1 and 1 and Q be 1 plus H. Find the gradient of the secant. Hence, so I'll use that gradient and I'll use a limiting process to find the tangent of the line. Okay, so to sketch the graph first, so I'm going to have this is going to be my truncus of f of x equals 1 on x squared. So I have an asymptote here at x equals 0, and at the point 1 and the point 1, that's going to be point P, and this is going to be point Q, which is 1 plus H, and f of 1 plus H. Okay, so the gradient of the secant will be f of x plus h minus f of x over h. And f of x plus h will be 1 on x plus h squared minus 1 on x all over h. My numerator has a fraction minus a fraction, so I need the lowest common denominator, and that will be my two denominators multiplied. So x plus h squared times x, multiply the x over to there, minus multiply that over to there, that's x squared by the way, minus x plus h all squared. And I've also got that over h over 1, which is the same as having h in the denominator. So that's going to be x squared minus x squared minus 2xh minus h squared all over h, x plus h all squared times x squared. These sum to 0. I have a common factor of h, so I take the h out, which gives me minus 2x minus h all over h, x plus h squared x squared. The h's cancel, therefore the gradient of the line P to Q is minus 2x minus h over x plus h squared x squared. So that's that first bit, part A. Part B then says, find the gradient of the tangent. So the tangent will be the line that touches at point P. And I know one point on it is 1, 1. I need to know its gradient. The gradient will be the instantaneous rate of change at point P, and that will happen when I limit h to 0. And that will give me the point at any point h. So if I limit h to 0, I'm going to have minus 2x minus 0 over x plus 0 squared x squared, which is minus 2x over x to the 4, which is minus 2 over x cubed. So minus 2 over x cubed will be the derivative using first principles. At point P, x equals 1, so the gradient at point P will be m equals f dash of 1, therefore minus 2 on 1 cubed, negative 2. So the gradient of my line is a gradient of negative 2 and has the point 1 and 1, therefore y minus 1 equals negative 2x minus 1, y equals minus 2x plus 2 plus 1 minus 2x plus 3. So it's going to be the equation of my tangent at x equals 1, y equals minus 2x plus 3. Just to recount what I did, I used first principles to find the gradient from P to Q, and that's going to be this, in terms of x and h. At point P, x is 1 and h will be 0, So therefore I found my derivative and then I could find my tangent line.